Good. All right, so today we are going to review for the final exam, okay? And I'll send out an email also that has all the information for the final, but just so you know, I am going to, your final exam will, so finals week doesn't actually start until a week from tomorrow, which is May 5th. So that's when I'm going to open it, and it'll be in Math Lab. It's just going to be like another assignment like you always see in Math Lab. Okay, so it'll open on Wednesday, May 5th in the morning. And then just like always, just so it's not confusing, all your assignments all semester have been due on Sunday. So that's what I'm going to make it do. I'm going to make it due Sunday, May 9th. Also, right now it says that this week due is the final exam review, but I'm actually going to make it also due Sunday, May 9th. I'm going to change that because I don't want it to be, right now it's due May 2nd, which is this Sunday. But then say you took it May 2nd, but you wanted to re-look at the review again right before you took your final, just to kind of remind yourself. So I'm going to keep the final exam review open as long as the final is. Because remember, you can take it as many times as you want since it's set up as a quiz. So you won't have to, there won't be a delay or a period where it's not open for you. Okay, so I'm going to change that. I need to put that on my to-do list. I'm going to change that for you today. I'll change the due date for the review from the 2nd to the 9th. Okay, let's get started with this review. Again, it's 20 questions. It'll all be multiple choice. So, looking at number 1. I've got negative 27.1 minus A equals 19.4. And we're solving for A. Okay, so this is way back when, at the very beginning of the semester, when we were solving equations. Okay, remember, you always want to make sure that your equal sign stays in its spot. You don't want to accidentally move it around. So remember, if we're solving for this A, we want to remove everything that's on the side of that A. So let's see, the first thing you need to get rid of is this negative 27.1 or that minus 27.1. So I'm going to do the opposite of that to knock it out. So I'm going to add 27.1. If I do it to the left, I have to do it to the right. So that gets rid of this part, but I still have negative A. Don't forget to bring down that negative sign. It's going to make a difference. So I have negative A equals 46.5. But what is hooked on to this A? If there's a negative in front of it, it's like there's a negative 1 hooked on. So remember, how you remove the hooked on numbers is you divide by whatever it is. So I'm dividing by negative 1. That cancels the negative 1 and turns that into plain A equals. What happens to something, no matter what it is, if you divide it by negative 1, it just changes its sign. So that's just going to turn that into negative 46.5. And if you have the sheet printed off, you will see that that is in your options, and it would have been option D. But be careful, they're also going to definitely put that positive 46.5, which is what you would have gotten had you not divided by that negative 1 at the end, right? That's what turned it to negative 46.5. All right. Number 2. Solving this one for K. So again, let's go ahead and bring down our equal sign so we don't accidentally move it around. Get rid of your parentheses. How do you get, when you have parentheses in your equation, you've got to remove them, and you're going to remove them by distributing whatever is bumping up against them. So that one will distribute the 6. This one has a negative bumping up against it, so I will distribute it. So here, 6 times K gives me 6K minus 6 times 5 gives me 30. When I distribute this negative to these terms that are in this parenthesis, it's just going to, again, change their signs. So it turns this into a minus 5K and that into a minus 4. And I still have the 3 on the other side. Now, once you distribute, you're probably going to have some like terms to combine. So let's see. On the same side of my equal sign is what I'm looking for to see if I can clean this up. I can combine this K with that K. So I have 6K here, but if I take away 5K, all on the same side, it's just going to leave me with 1K or K. I can also combine this negative 30 and that negative 4, since they're on the same side. Remember, we called this just putting the like terms in the same basket. So I have negative 3 and negative 4, which just gives me negative 34. And then if I bring down this 3 over here, still haven't done anything with it. The only thing that needs to happen for this K to now be alone is to get rid of the minus 34 with a plus 34. So K, there's my equal, 3 and 34 gives me 37, which again, if you have it printed off, 37 was the A option. Okay. Number 3. A high school graduating class is made up of 425 students. So there's 425 students total. There are 153 more boys, or excuse me, more girls than boys. How many boys are in the class? So let's see. We've got boys and girls. And if you add the boys and the girls together, all together, there are 425 students. That's what I know. I don't know how many boys there are. I don't know how many girls there are, but I know if I add the boys and the girls together, it's going to be 425. What I do know is the girls have 153 more than the boys. So what I'm going to do is I'm going to call the boys my X. If I add that to the girls, if the boys are X, what can I call the girls? They're going to also be X, but plus 153, right? So if I call the boy, again, I have no idea how many boys there are, but I do know that the girls have the same amount as the boys, so they also have X, but plus 153. So there's my boys. You can kind of even think of it like this. There's my girls. If I add them together, I get 425. So now let's just solve this for x. So on the left, let's see, do I have like terms? Yes, I can put this x with that x. I actually have two x's over here. So 2x, just bring down the 153 equals 425. See where this is going? I'm going to be able to solve this for x. So let's see, get that x by itself. So I'm going to get rid of that plus 153 with a minus 153. So now I have 2x equals, let's see, 12 is 272. Still solving for x. I need to get rid of the hooked on 2. We get rid of hooked on numbers by dividing. So the 2 goes away. There's my x all by itself. And when I divide 272 by 2, what do you get? 136. So let's see. What does that represent? Who was represented by just the x? The boys were, right? The girls were x plus 153. And it's asking me how many boys are in the class. Well, if the boys are represented by x, that means there's 136 boys in the class, which would have been B on the multiple choice. If they would have asked you how many girls were in the class, what would you have done from here? Once you got that 136, what's representing the girls? The x, which would have been 136 plus 153. I would have had to add those together. Okay, but it didn't. It asked me for boys. I'm just saying if it did ask you for girls, you would have had to go further, right? All right, number 4. Solve for the variable in the inequality shown below, then graph the solution. So you have 10n minus 2 is greater than 9n plus 8. So just like always, you're just going to bring down your symbol, even though it's not an equal, it's a greater than, but you just want to keep it straight. I need to move this n over here, right? If you've got n's on both sides, you need to move the small one to the big one. So let's see, I'm going to subtract 9n from both sides. So on the left now, I've got 10n minus 9n, which is just n. Drop down the minus 2. Drop down your greater than, and all I have left on the right is that 8. Get rid of the minus 2 with a plus 2. So now I have n is greater than 10. So let's see what that looks like on the number line. So there's my 0. There's my 10. Where are the numbers bigger than 10? That way, right? These go bigger going to the right, which means my arrow is going to go to the right. And now I need to decide what kind of symbol I'm putting on the 10. Now remember when we did these, it's either going to be a parenthesis or a bracket. So when we have just a greater than or less than, it's going to be a parenthesis, right? So gives you the bracket, right? If it has that equal to line below the greater than and less than symbol, those are what makes brackets. If you just have greater than or less than, it's going to be a parenthesis, not a bracket. So I'm going to have a parenthesis on +10 with the arrow going to the right. So since this is multiple choice, you can, even though we haven't done the interval notation part of it yet, first of all, those two deal with 6s. So this one has 10 and this one has 10. But remember, where does your arrow need to be going? It needs to be on the 10, which both of those are. So it needs to be on 10, but the arrow needs to go to the right. So that's why you would pick that C. In interval notation, that's when we did that, right? We did the line first. Remember, positive infinity is that way. Negative infinity is that way. So that's what told us that we were going from 10 to positive infinity. Okay, number 5. Says to evaluate 3 to the 0 plus 8 to the 0. So on this one, we need to remember what happens when you raise something to the 0 power. When you raise something to the 0 power, it is equal to the number 1, just plain old 1, which means 3 to the 0 is 1, plus 8 to the 0 is 1. So if I add 1 and 1 together, I get 2, which would have been A on the multiple choice. Right, number 6. Perform the indicated operation, and we have 5 into the 6 minus 6n plus 6 into the 4th. Plus, we're going to add it to this parenthesis, 7 into the 4th, plus 3 into the 6th, minus 9n. Now, when you are adding, this just means to combine like terms. And I can't see anything in writing. So that's what, when you are adding, all that means to do is combine your like terms. And you want to start with the highest exponents. So let's see, my highest exponent is the 6, right? So I need to find if there's any other into the 6s to go with this one. And I'll look all the way through everything. Here's another one. So you're just going to add the coefficients, right? When you are adding and combining like terms, your exponents are not going to change. If you have 5 of something and then you put 3 more of that same thing with it, it's not going to change what you have. It's going to change the amount of those you have, but it's not going to make into the 6s change to something else, right? You are just putting the same things in one basket. All the into the 6s are going together in one basket. They're still into the 6s. Okay, so if I've got 5 of them here and 3 of them here, all together I have 8 into the 6s. Now, what's my next highest exponent? The 4. So let's see, I've got those and those. So let's see, I've got 6 into the 4th here and 7 into the 4th here. So if I add my into the 4ths together, 6 and 7 gives me 13 into the 4ths. And the last one, let's see, I've got that in and this in. Be careful, because how many do I have here? I've got -6 plus -9. If you want to type that into your calculator, remember, you've got that calculator. So I've got -6, then plus -9. So that's what I'm adding together, right? They're ends. I've got -6. And when I add that to -9, it gives me -15. So I've got -15 ends all together. So be careful on your multiple choice here, because look how similar they look. That's the downfall of a multiple choice test, is that when you get problems like this, a lot of them are going to look the same. So what I would do first is go through, actually this will get you your answer, because if you go through and you just look for who has 8 into the 6s, so you can cross out any of the ones that don't. Well, that doesn't have 8. That one's, there's my into the 6s. It says it has 13. There's 8 into the 6, so that one's good. And who knows what that is. So this is the only one that has 8 into the 6. So just see, make sure the other 2 terms are correct. But that's what I would do. I would look at one term at a time and put a line through the ones that don't have that term, so you don't come back and look at them again. All right, number 7, find the product. I've got 7y plus x times 7y minus x, right? So if we're finding the product, that means we're multiplying. There's not a plus or any kind of symbol in between these 2 parentheses, which means you're going to multiply them together, which in this case, that means you're going to FOIL, right? If your 2 things that you're multiplying together each have 2 terms in them, then you're going to FOIL, which means there's your first, multiply those together. 7y times 7y gives me 49. Now I'm multiplying, so my exponents do change because I add them. Y times y gives me y squared. So 7y times 7y gives me 49y squared. Then my outer, careful with your signs, I've got 7y times -x. So I've got, first of all, I'm just going to think about my signs. I have got a positive times a negative. It's going to be negative, right? So what do I have? 7y times x. When you multiply 2 letters together, they just stick themselves together. I'm going to write them in alphabetical order. So I'll have 7 and then xy. Then my inner. Watch your sign. A positive times a positive, so it's going to be a positive. I've got x times 7y. So again, this term, then I'm just going to give this an x, and I'm going to put it in alphabetical order. X times 7y gives me 7xy. Positive x times negative x. A positive times a negative will definitely give me a negative. So go ahead and put your sign in. X times x gives me x squared. So after you That's when you're going to want to look at your middle terms. If they have the same letters, that means they're like terms. They're both xy's. So I need to put them together. If I've got -7 here and +7 there, well, those xy's, just cancel those. So all I'm left with is the 49y squared and the minus x squared, which would be C in the multiple choice. Okay, number 8. X squared. We're going to factor out the greatest common factor. We've got 3x squared y to the 6 plus 12x squared y to the 5th. Okay, when we're factoring out the greatest common factor, we're seeing what, in this case, 2 terms have in common, and we're going to pull it out. We're going to do each thing individually. We're going to do the number part first, then the x's, then the y's. Okay, so don't think of it all together. Don't get overwhelmed and think of these all together. Let's just look at the number part first. We've got 3 and 12. Okay, what I want to do is always look at the small number and say, okay, what are the factors of 3? Or in other words, how do you multiply to get 3? Well, there's only one way, 3 times 1. So I'm going to look and see, does the 3 also go into 12 evenly? It does, right? Which means they've got a 3 in common. So you're going to pull that 3 out. Now do your x's. So let's see, this one has x squared, and this one has x squared. You're actually looking for your smallest exponent, but in this case, they're the same, which means they've got x squared in common. So I'm also going to pull that out. Y to the 6th, y to the 5th. So here, looking for the smallest exponent, I've got y to the 5th as my smallest exponent, so that's what you're going to put out. Now you're going to put in parentheses what is left. To find what is left, whatever you pulled out, you're going to have to divide these by that, which means I like to just go ahead, whatever I pull out, write it underneath everything that I'm pulling it out of. So let's see. I pulled out the 3. I pulled out the x squared. I had y to the 6th, and I took out y to the 5th. So if I subtract those exponents, I'm just going to be left with a y. So again, I pulled out all the number, I pulled out all the x's, and I pulled out all except for one of those y's. Go to the next one. Plus 12 divided by 3 gives me 4. I had x squared, but I pulled it out. I had y to the 5th, but I also pulled it out. So I don't have anything left besides that 4. This is another one where you're going to have to be very careful. Look how similar those multiple choices look. The first thing I would do is say, okay, these are the only 2 that have y plus 4 in parentheses. Then just make sure this one had x squared y to the 5th in front, and this one had the 5 and the 2 flip-flop. So you're just going to have to be very careful, and it is multiple choice, so use multiple choice test-taking skills and go through, and any one that is for sure not an answer, take it out. Number 9. 12. Now remember, when it tells you, anytime you're factoring, you're always, always, always looking for greatest common factor first. Because if there is something in common, you've got to take it out before you do anything else. So let's see, they don't all have x's because this last term doesn't have an x. So the only thing they could possibly have in common is if there's a number that goes into 6, 21, and 12. So again, I'm going to use my small number and say, okay, to multiply to get 6, I could do 6 times 1 or 3 times 2. 1 doesn't ever help us, right? Because 1 goes into everything, so it doesn't change anything. What about 6? Well, I know it goes into 6. It also goes into 12, but it doesn't go evenly into 21, so it's not 6. But what about 3? It goes into 6, it goes into 21, and it goes into 12. So there is a 3 in common with all these terms, so let's pull it out, right? We already looked, and we can't take anything else out because this one doesn't have any x's. So all I'm pulling out is the 3. And putting in parentheses what's left, which means I need to divide all these terms by 3's. So 6 divided by 3 gives me 2x squared. Minus 21 divided by 3 gives me 7x. Minus 12 divided by 3 gives me 4. Now it said to factor it completely. It didn't just say to pull out the greatest common factor and be done. So I need to see if what's left inside those parentheses will factor some more. This is that long kind of trinomial factoring where you have to multiply the outside numbers together. So I've got 2 times negative 4. Be careful with your sign because that's going to give me a negative 8. Now remember how we did this because our next chore is to find out what multiplies to give me negative 8 and at the same time adds to negative 7. Now, negative 8's not too bad a number, but let's say you had a bigger one. So let's just go and look at how you would do this. So you would go to your y equals button. Then whatever you're trying to find the factors of, which in this case is negative 8, you're going to put that there. So negative 8. And then remember what we did. We did divided by, and then we hit this X button. Then we went down and we typed in the same exact thing here, but we threw in a plus X at the end. So again, negative 8 divided by X. This time add a plus X. Oh. Okay. Now we're going to hit second table. So what you're looking for in this last column here is whatever the middle number is, which in this case is negative 7. So I'm looking, I need to go up, right? They're going positive this way. So I need to go this way. Oh, there's negative 7 right there, which means I'm going to use a negative 8 and a positive 1. Now, with those numbers, I'm going to create 2 fractions. The denominator of both of the fractions is going to be whatever this is right here. So in this case, it's a 2x. After you put the 2x under there, you're going to reduce the fractions that reduce. Let's see, 1/2 doesn't reduce, so I'm going to leave that one alone. But what does negative 8 over 2 reduce to? It reduces to negative 4. So after you reduce, that's where your factors come from. The bottom, so the 2's gone, right? Because it turned into negative 8 over 2, turned into just a 4. So all I have left down there is an x minus 4 up top. And then same thing here, 2x plus 1 Now, remember, what did you do at the very beginning that was part of the factoring, and it is part of your answer, is you pulled out that 3. So again, when you are looking, first things first, the only ones that have the 3 in front, which means they pulled out the 3, are B and C. Now, just make sure you have your signs right. Make sure the X is with the -4 and the 2X is with the +1, right? See how these signs are flip-flop from what you need, right? You need X -4 and 2X +1. Number 10. Write the rational expression in lowest terms. I've got a squared minus 25 over a squared plus 7a plus 10. So let's see. Before you can start simplifying or reducing the top and the bottom of your fraction, any part that needs to be factored, you have to do that first. Okay, so I'm going to call this factor, then cancel. So up top, there's only 2 terms, so it's not a trinomial. I'll look for anything in common, but there's not anything in common, but I do notice that these are both perfect squares, right? So they are going to factor perfect squares with a minus in the middle. How do you get a squared? A and A. How do you get 25? Using the same number, 5 and 5. Now, the good thing about difference of squares is you don't ever have to think about signs. They're always the same sign combination. 1 plus and 1 minus, and it doesn't even matter where you put the plus and the minus. You just have one of each. Now, this one, it's a trinomial. So it's going to have 2 factors also. It's not the long kind of trinomial where we have to multiply our outside numbers because it's just a squared. There's only one way that that's going to happen. A times A. So now what are you doing? You're trying to find the numbers that multiply to give you 10. We could do that in my calculator, in my y equals. It's just that there's not many ways to do that. What are you looking for? The pair that adds to +7. So we need a +5 and a +2. So there took care of our factoring. After factoring, then we cancel. So I'm looking for any of the factors that are the same and canceling them. So all I'm left with in the top is a minus 5, and in the bottom, a plus 2. And again, all of them are going to look so similar. We'll go through first and knock out anything that didn't have a minus 5 up top. And then go from there, right? Process of elimination. All right, number 11. M squared minus 7m over m minus 4 plus 12 over m minus 4. So when you are adding 2 fractions and they have the same denominator. Remember how we did this? We rewrote the fraction all over whatever the common denominator was. We turned these two fractions into one fraction because they have the same denominator. Now I'm just going to rewrite all my numerator over this. So I'm going to have m squared minus 7m plus 12. So now, just like the last one where we had to factor and cancel, that's what you're doing here. So if I factor this, the good news is nothing you can do with m minus 4. Kind of looks like a difference of squares, but this m would need to be squared, right? So that's why it's not. So I just brought it over. Now, this one's a trinomial, but it's a good one because it's just m squared, which means just m and m. Factors of 12 that add to, be careful here, -7. So if you're not comfortable, let's go to our y equals again. This is the number. You're trying to find the factors of 12. So 12 is what we're using here. We clear it out. So 12 divided by x. And then do it again. 12 divided by x plus x. Second table. What's my number in the middle? -7. So let's see, oops, over here in the third column, let's just go down. Actually, go up to where this is 0. I need to go make these negatives. So here comes my negatives. -8, there's -7. Who makes that happen? -4 and -3. So I'm gonna have -4, -3. So after you factor, what do? You're going to cancel those m minus 4. So all you're left with is m minus 3. Right, number 12. We're into the graphing part. Graph the linear equation. It says x equals -5. Now, anytime you do not have a y in the equation that you're graphing, you just have an x, this is going to be a vertical line. Vertical lines go straight up and down. So where is it going to be? Where is x -5? Here's my x-axis. So let's see, 1, 2, 3, 4, 5. -5 would be over here. If I'm going to be a vertical line going through -5, it's going to look like this. Just a straight up and down line going through the x-axis at -5. Okay? So again, here's the two that have vertical lines. Looks like this one goes through +5 and this one goes through the -5. Okay, the other two lines aren't even vertical. Number 13. Find the slope of the line, and it's giving me the equation -4y equals -3x minus 18. If you are asked to find the slope of a line and you are given the equation of the line, you want it to be in slope-intercept form, because once you get, which just means that you want the y by itself. Because once you get the y by itself, the number hooked on to the x is your slope. But that's not the case until y is all the way alone. So the first thing I need to do is get y alone, which means that negative 4 is hooked on. So how do you get rid of hooked on numbers? You divide by them. Cancel it. So here's my y equals, which is good, right? It's matching this. So let's see, a negative divided by a negative turns that into positive 3/4x. Another negative divided by a negative gives me positive. This number will reduce to 9/2, but you could actually even get this number wrong. This problem doesn't have anything to do with this number. It just wants to know what's the slope. Well, once the y is by itself, the number hooked on to the x is your slope, which is 3/4. Right, number 14. All right, use the geometric interpretation, which just means use this graph. Find the slope of the line. So here's the easy, this is just a test-taking clue that I'm going to give you for this particular problem. Now, it gives you a line, and it's very distinct about these 2 points. So it didn't even put points on them, but let me show you. Hang on, let me erase this. So if I have to have 2 very specific points if I'm going to use the rise and the run. But if you'll look at this, it is crossing through that y-axis at that +6, and it's crossing through this x-axis at +3. So I think the best way to go about this is to name the coordinates of these points. Let's say what this point is. Let's see, if it's on the y-axis, that means its x is 0, right? To get to this point, I don't move anywhere on the x. I just go up 6. So there's that point. This point, I can do the same thing. This time, I do move on the x. I go to +3 for the x, but I don't go up or down, which means my y is 0. So now there's 2 different things I can do to find the rise over the run. I can either use my counting and go down 1, 2, 3, 4, 5, 6, and then run 1, 2, 3. So if I use that method, which is rise over run, what did I do to get from one point to the other one? I had to count down, which means my rise was going down, which is a negative move. So I went down 1, 2, 3, 4, 5, 6, which means my rise is -6. And then my run was 1, 2, 3, positive, right? Positive. And then -6 over 3 reduces to -2. So the slope of that line is -2. But it wants you to take this a little bit further. It doesn't just want to know the slope. Actually, that will get you your answer. But by identifying then it wants you to find the equation of this line in this form by knowing the slope, which is -2, and the y-intercept. The y-intercept is where it crosses the y-axis, which is 6. So the slope is -2. The y-intercept is +6. So if I put the -2 here and the +6 here, right? This is the number that's your y-intercept. So let's look what that looks like. Y equals, what's the m, or in other words, the slope? So -2 here. X plus, what's your y-intercept? My y-intercept is +6. So there's your equation of the line. And again, actually just knowing, being able to figure out what that slope was, this B is the only one that had the -2 hooked onto the X, right? All the other ones had something else. So just knowing, finding the slope gets you that right answer using process of elimination. Okay, number 15. Graph by using the slope and y-intercept. And it's in y equals 2x minus 6. It's in the form that we want it to be, right? It's in this slope-intercept form, which means I know what the slope and the y-intercept are. The slope is 2. The y-intercept, what's in the B spot? What's in this last spot? -6. Now, look at all the graphs on these. Again, this is just a clue to help you when you're taking this test, what's happening on these graphs. Do you see how this is -10 and that's +10? What does that mean about each one of these hash marks? If that's already to -10 and that's to +10, that means each one of these hash marks is 2, isn't it? 2, 4, 6, 8, 10. So we need to, when I draw my graph, I'm going to draw it like that. Right? So 2, 4, 6, 8, 10. -2, 4, 6, 8, -10. So I'm trying to make my graph that I'm going to use match the ones that are going to be in the multiple choice. The y-axis does the same thing. 2, 4, 6, 8, 10, and -2, 4, 6, 8, -10. So the first thing you're going to do is go find the -6 on the y-axis and put a point on it. That's what the y-intercept does, is tell you where it crosses the y-axis. Now, remembering that these are going by 2s, right? So that's -2, -4, -6. So it's actually right there. Now, from here, I count out my slope. Actually, even before I do that, I am going to my options, even before I count out my slope. And I am taking out any option that doesn't cross through the y-axis at -6. So let's look at these. This one. Yep, that one crosses through at -6, right? Because there's -2, 4, 6. So that one's good. But look, here's my y-axis. It needs to be crossing through right here, which means it's not B. This one, it does look like that one's crossing through at -6. So that one's good. And this one's good. So it didn't help us a lot, but we know it's not B. But all 3 of these graphs cross through the y-axis at -6. So now let's look at what our slope is telling me to do. Remember, your slope needs to have a top and a bottom. So if it's a whole number, put it over 1. So let's see, 2 over 1. The top number is your rise. The bottom number is your run. So my rise is up 2. My run is to the right 1. Starting from here, if I go up 2, remember every hash mark is a 2, right? So I'm just going back up to this next hash mark. Run 1. Now remember, this is 2 because their hash marks are 2. So if I run 1, I'm just running right into the middle of that. So and then connect them. So let's see what else we can knock out. Let's see. It starts at the bottom on the left and goes up to the right. Let's see who's still in. Look at this one. Where does it start? It starts up and goes down, so it's not A. These both do go up to the right. So now we need to see. Let's see. Can't do it upside. I can't do it backwards. So if I go up 2 over 1 on this one, if I go up 2, it's to right there. And then over 1 would be right here. This one is not, that one's not steep enough, right? This one is the one that goes from here up 2 and then barely over 1. So that's why it would be D on that one. Okay, so you've got to be very careful. I hate that these graphs go by 2s. All right, let's look at number 16. X plus 8y equals 8. And it wants me to graph this one doing the same thing, using the slope and y-intercept. But this time, it's not ready to graph yet because the y is not by itself. So that's what we need to do first. Remember, hooked on numbers go away last. So let's get rid of the x first by subtracting the x from both sides. So now I have 8y. Drop down my equals. Drop these down, right? Because I can't put those together. They're not like terms. So I'm just going to have a negative x and a plus 8 over here. Divide by 8, everybody. Get rid of that 8, so my y will be by itself. So let's see, what's in front of this x? I don't see a number up here with the x, so it's a 1. So it's a negative 1 over 8. X plus 8 over 8 reduces to 1. So now it's in slope-intercept form, which means now I know the slope is negative 1/8, and the y-intercept, which is this number not hooked onto the x, is positive 1. So again, the hash marks are 2s because that's 10. So we're going to do the same thing. It crosses through. What's my y-intercept? Positive 1. Now remember, that's 2, 4, 6, 8, 10. So if that's 2, that means it's crossing through at positive 1, which would just be right in the middle. Actually, this helps a lot on this one. By just knowing that. Let's look at where these all cross. Whoops, wrong one. Look where this one crosses. It's somewhere up here. Positive 1 is in between 0 and 2. It doesn't cross through there. Look at this one. Where does that one cross through? Crosses through down at -1, it looks like. This one crosses through, if that's my 2, look where it crosses, right in the middle of that. So that one crosses at 1. So these two are out. This one's still in. Where does this one cross the y-axis? If I'm looking at this one, it's crossing down here somewhere. Positive 1 is right there. So it's not that one either. There's only one of those graphs that crosses through at positive 1. Okay, the C graph. But let's go ahead and do our rise and run. In this case, our rise is negative. So we're going to go down 1 and write 8 from here. You went back down 1, which would just be back down to the origin, right? Because that's back halfway down. And then run 8, 2, 4, 6, 8. And then connect to them. Which does match that C graph. But again, I would always plot the y-intercept first. Take out any graphs that don't cross the y-axis at that spot. All right, number 17. Graph the line through the given point with the given slope. So it tells you there's a point at 0, 3, and it tells you the slope is -1/5. So it's actually the same information you get with the slope-intercept form, right? I know the slope, and that's actually the y-intercept, right? Because if the x is 0, that means that's your y-intercept. So let's look at what this looks like. Do these go by 2s? And they do. So 2, 4, 6, 8, 10. -2, 4, 6, 8, -10. 10. -10. So let's put a point here. 0, -3. Where is that? Where is 0, -3? If my x is 0, I don't go left or right at all. I go up 3. But again, okay, the people that are here getting this benefit of recognizing what's happening on these graphs. If I go up 3, where is that going to be? It's going to be in between this 2 hash mark and this 4 hash mark. So now I would go to my graphs and take out any of them that don't cross through there, okay? So let's look here. Crossing through right between the 2 and the 4 lines. So this one's good, right? There's 2, there's 4, so it crosses at 3. Here, there's 2, there's 4. That one may cross at 3. I'm going to leave that one in. But look, where's this one cross? -3. So it's out. Where does this one cross? Negative something. So it's out. So I'm only down to A or B. So from there, then I need to do my slope, my rise and my run. If it's negative, just make your top move your -1. So if my rise is -1, I'm going to go down 1, right 5. Starting from here, if you go down 1, right, I'm at the 3. So if I go down 1, I'm just back to this 2. And then I'm going to go over 3. So be careful, right, because this is right in between. If I went over 3, it would be right in between that 2 and 4. And then connect them. So let's see. What did we narrow it down to? A or B? So if you will look at A and B, look at the B. Look how steep that is, right? This one, if it went down, if it started here and went down 1 and then over 5, I started here, went down 1 and over 5, it's going to be somewhere over here. Oh, what did I do? Y'all should have stopped me. Where did I didn't go over 5, I went over 3. I was looking at 3.
I was just going to say something.
I was going to say, why didn't y'all stop me? Because what is I went down 1 over 5. I don't know where I got 3, which would mean what? Down 1. So if I went down 1 over 5, if these hash marks are 2, there's 2, 4, 6. So it's going to be in between 4 and 6 for the 5, which will be right here. So again, down 1 over 5. If I'm looking at this one, if I went down 1 over 5, I'm somewhere over here, right? Just like this one is. Down 1 over 5, right here. Okay, number 18. Write an equation of the line through the given point with the given slope. Write it in slope-intercept form. Here is another benefit of watching this video. The point that it gives me is 0, 4. The slope that it gives me is negative 3/4, and it wants me to write the equation in slope-intercept form, which is that y equals mx plus b. Well, that number is your slope. The number here is your y-intercept. The plus about this problem is it gives us, it's calling it a random point. It's just saying the point, but this is my y-intercept, right? If my x is 0, that means that's where it's crossing the y at positive 4. Okay, which means I just need to put the negative 3/4 in the slope spot and the 4 in the y-intercept spot. Okay, if this number was anything other than 0, then it would be a whole other problem. But it's not. It's not going to be. If that's a 0, then the number in your y spot is your y-intercept. So if I wrote this out, I'd have y equals, put this number in place of my slope, so negative 3/4 x. Put this number in place of my y-intercept, so plus 4. Which is A if you're looking at the multiple choice. Okay, 2 more. Number 19. Okay, a cable TV company charges $26 for basic service. Plus $5 for each movie channel. Okay, so what this says is no matter what, your bill is going to be $26 up front, right? Everybody's getting charged the $26 just for having the cable. Now, every time you add a movie channel, you're going to have to add $5 a month. Okay? What it wants to know is what is the fixed cost. It actually says let Y be the total cost in dollars of subscribing to cable TV using X movie channels. So if I wrote this out, I would have Y equals 5 times this X is going to be however many movie channels you have, right? So that's going to be, so if you had 6 movie channels and it charged you $5 a month for each movie channel, you'd have 5 times 6, which is $30, right? This number is what's added on at the very end, right? Doesn't matter how many movie channels you have, you still have to add that $26. Everybody has to have that. It wants to know which one of these numbers is the fixed cost, the one that stays the same for everybody. It doesn't change no matter how many movie channels you get, which means that number right there. That is your fixed cost, which is B. The fixed cost is the one that's the same for everybody and it doesn't change no matter what. Last one. Perform the division. You've got m to the third, n to the third, minus mn to the third, all over mn. So whenever you have a division problem, the denominator is going to be the denominator for every term up there. So the first thing I'm going to do, even though it takes a little bit of time up front to rewrite it, especially when I got a bunch of different letters with different exponents and things like that, to help me not make a mistake, I'm going to write them each over this mn. So I'll have m to the third, n to the third over mn.
I can't tell everything's
Then the minus, and then this one. So m n to the third over mn. So I just separated them and made them each their own fractions. So now, remember, all I have to do now is if I'm dividing, I'm subtracting exponents. And remember, there's not an exponent, it's a 1. So now if I had m to the third over m to the first and subtracted their exponents, I'll have m squared. N to the third over n to the first, again subtracting, so it'll be n squared. Bring down my minus. I had the m, but I divided it, so the m's gone. What do you get when you subtract these exponents? N to the third over n to the first. If I subtract those, I get n to the second. Again, it's multiple choice, so I would definitely be very, very aware when I am comparing what I have on my paper to comparing what they have here. So A's out, right? Because it has m to the fourth, n to the fourth. So these all have m squared, n squared. So what's my last part? Minus n squared. So that's why that is the B one, right? It's the only one that has m squared, n squared, and minus n squared. Okay? All right, so that is what your final is going to look like. Okay, so what I would do is, remember, you can work this assignment, this final exam review in Math Lab as many times as you want. Okay, I would work it through until I get the grade that I want to get on my final. Okay, and you can't hurt yourself taking it multiple times. It doesn't even average the times together. It just takes whatever your highest score on it is. So you don't have to worry about it. If you took it first and you made an 85 and you're happy with that, but you just wanted to take it again to see the problems again, and something happened and you made a 75, you still get the 85. You can't bring your grade down by retaking the quiz. Okay? So it says it's due this Sunday, May 2nd, but it's actually going to be due next Sunday, May 9th, the same day that your final exam is due. And I'll go in and change that right now. So let's see, I got Highsmith, Sorg, Flanagan, Ware, and Cook.
Is it open already to do the review?
The review is.
Right, okay.
Yes, the final, it should be. The I can't open the exam until next Wednesday, but the final exam review is open. I'm double checking right now.
Okay, so with review, are you keeping the review questions that we do the same as the final test, or you switching it up?
The order of them will be the same. The numbers will be different. Like your number one was negative 27.1 minus A equals 19.4. It may say negative 36.2 minus A equals 14.5. So it'll be the same process to work the problem. It'll just have different numbers.
Okay, okay.
But it will go in the same order. The order that you had the review will be the same order that you take the test.
Okay. It's the same like as usual. That's all I want.
Right.
Thank you.
Uh-huh. Oh, yours,
But do we have class Thursday?
huh?
Are we doing anything Thursday?
So I'm going to be live, but it's just going to be, you can just log in if you have any questions. Okay. I don't want to not hold class. That way, if somebody did have questions, then I'm here and live to ask them. But if you don't have any questions, I'm not going to take attendance. So if you don't have any questions for me, I'm not doing anything new.
All right. Well, thank y'all.
Uh-huh. Oh, let me stop recording.